Mr. Sunkar, welcome. You have charge of member infrastructure, but people here are more interested in bullet train. When will they be able to travel on that bullet train? I'm sure this could be the last question, but I'm deliberately asking you the first because this is behind everybody's mind that they want to travel in a higher speed train, safe train. When can that dream come true?
We are planning to do the trials in June 2026. On completion of trial, we will be in position to run then this bullet train in selected stretch in 2026 itself.
2026, we can have bullet train running
bullet train will
on
be
the Indian
there
soil.
on road. Yes, it will be there.
Okay, sir. So we are looking forward to 2026, but maybe around last general elections, the conversation was that maybe by 2024 we can have it. We lost some time because of the COVID, but what was the roadblock which you had seen, especially from the land acquisition side? Are we confident that entire land now is in the possession of your department? What is this scenario like?
There were initial hiccups. As usual, for land acquisition, there are a large number of issues, emotional issues. Nobody wants to part with the land, and then issues related to ownership. Then issues related to environmental clearances, forest clearances, other statutory clearances. All these problems were there, but now issues related to land acquisitions are over. Almost 99% of the land is available with us. 100% in Gujarat, and only barring 1 hectare of land in Maharashtra, entire land has been acquired. So land issue is over.
So civil work, how much have you completed? What sort of scenario is there?
For civil engineering works, we have awarded the contract for entire stretch of 508 kilometers. Out of his 352 kilometers falls in the state of Gujarat, for which work is progressing at much faster pace because contracts were awarded earlier, and progress made so far is so good that almost 300 kilometer stretch we have done the foundation work. Then piers are ready, almost more than 200 kilometers stretch, and this deck is ready for laying of the track, more than 100 kilometer stretch. So that is this is the situation, and linking of track has just started.
Mr. Sunkar, when this project came to India in 2015-16, the conversation was about Make in India. But now we are into that, things have to be made in India. There is a self-reliance, campaign going on. What is to your mind, can be, Japanese collaboration where Japanese companies can come into India, make things here, and then, we can deploy them into the Indian high-speed networks?
If you see, as far as the civil engineering part is concerned, with the help of engineers and their agencies, we are in position to execute these civil engineering works by deploying our own agencies, Indian agencies. All are Indian agencies. L&T, Afcon, SCC, all these agencies are working, and all work supervision of the work is being done by our own engineers. They are being assisted by Japanese engineers on day-to-day affairs. They are solving the problem wherever there is issues, but 70% of the project is costing, as per the total cost is concerned, 70% is civil engineering. So for 70% of the project, it is indigenization. So you can say that it is all make in India. We are making in India and by our own team.
And what about the train sets? Shinkashin has its own design. not only for signals but also for their cars, tracks. Do you think that since this is a first project and the limited understanding I have of the high-speed networks is that interoperability is very complex. Even in Europe, there are protocols, there are several complex systems where this intersections and interoperability happens between the trains. How are we designing it in the first place?
As we know, Japanese systems are very stringent. They follow the safety standards. Their safety standards are very high. They don't budge to relax any of these standards. So, and it is good for us. It is basically learning for us that we are changing our mindset. Where we have been working, we are following the methodology system being adopted there. And as you mentioned, this train, even this train set which is there in Japan will have to be modified to suit the Indian conditions. They have brought out certain issues and we have agreed because we are very clear in our mind. Ultimately, they have the technology. They have been working with the bullet train since 1964 and their safety record is so high. Their punctuality record is so high. So we have to honor them. We are following their guidelines, whatever they concern they are expressing, we are addressing, and I'm telling you, 100% compliance is being ensured by us to their observation. Whatever observations are there, we keep on discussing, and after discussion, after mutual agreement, we are proceeding further. And we have seen that they are not that unreasonable also. But only thing is, their systems are so rigid. Flexibility is very less. But it is our interest for safe running of the trains, for the safety as well as the punctuality is concerned. So we are basically following whatever the system they are wanting to have in our country.
Sir, if we talk about the Indian system right now, there are three type of tracks. One is this rapid transport system, which recently been launched by the Prime Minister. Second is one track which you are making. Third is the conventional tracks. We have seen best of the best networks in Europe or even in Japan or Korea. Trains can freely run on these tracks. But what is the scenario like when last time Railway Minister was around? So he was talking that 5,000 kilometers of track we are adding and renewing every year. Are we factoring in that tomorrow if higher speed trains need to run, these tracks are good enough and these facilities are good enough to run those tracks?
Ours is one of the largest rail network. 128,000 kilometers is the track length we are covering. And last year we added more than 5,000 kilometers. This year also, so far, more than 2,000 kilometers have already been added. And by the end of the financial year, we are aiming to cross this last year's figure also, and we should end up somewhere 5,500 kilometers. But question you raised is that regarding this speed, as we are aware that in our system, goods trains and mail express trains will have to run on the same track. Requirement of the technical requirement of the track are different for both the cases. For high speed, we need higher super elevation. When I say super elevation, one rail has to be at higher level as compared to other to suit the basic requirement of the velocity. Once the speed is there, centrifugal force will be there. To encounter that, we'll have to raise the rail, outer rail, as compared to the inner rail. And then this super elevation will have to be run down to when it reaches the level track, when both the rails are at the same level. So acceleration, rate of acceleration is the limiting value. So we have to factor that also. So because of that region, we will have to make the balance. For higher speed, we need more and more super elevation. For less speed, we need less super elevation. So compromise has to be done with this concept of kind efficiency and kind access. So that is why our speeds are limited. But during last 5 to 6 years, you can say, we have converted 11,000 kilometers of our track to have the speed potential of 130 kmph. Earlier, it was 100 kmph. In select routes, it was 110 kmph. Now we have already raised the speed to 130 kmph in almost 11,000 kilometers, 8,000 kilometers. We have identified for raising to 130 kmph. That will be completed by March 25. Similarly, for this stretches between Delhi to Bombay and Bombay to Howrah, Delhi to Howrah, in these sections, speed is being raised to 160 kmph. 160 kmph. For Rajdhani and Duronto type trains, so it will be 160 kmph. But as you asked a specific question regarding this, your
Interportability.
LCRTC, these trains are more or less, track is more or less same as what we are making. But only thing is they are adopting Western railways, Western countries concept, whereas we are going with the Japanese technique. This is the only difference. Standard gauge is same. Train sets are also more or less same. But in our case, Shinkansen, the best technology available in the world, we are going with that.
Ladies and gentlemen, this bullet train HSR is something which we have not seen in India, and something Indian Railways is also executing for the first time. I am told that Mr. Sunkar has also brought a film to showcase how he is taking the project forward. Maybe his team, if they are ready with the AV, ready, so we can play. So I'll get aside.
I can also come that side. Should I come that side? I'll come.
Dedicated toward the transformation of transportation, ensuring safety, reliability and sustainability, and contributing to the nation's technological advancement. The Mumbai-Ahmedabad high-speed rail corridor is all set to take a giant leap in the transport sector. The 508-kilometer long alignment of the Mumbai-Ahmedabad high-speed rail corridor will traverse through Sabarmati, Ahmedabad, Anand Nadiyar, Vadodara, Bharuch, Surat, Bilimora, Babi in Gujarat, and Boisar, Virar, Thane, and Mumbai in Maharashtra. The MAHSR project will reduce the travel time between Mumbai and Ahmedabad, give a boost to the economy, benefit sectors like tourism and infrastructure, and give thrust to the Make in India initiative. The project has already started generating direct and indirect employment. India will be using the world-famous Shinkansen technology for this project, which is known for its technological advancement and has a zero passenger fatality record in the past 55 years of its operation. The thematic design of each station on the route will reflect the essence of the city in which they are located. The architecture of stations will be an amalgamation of global technology with a taste of local culture. Inspired by the Dandi March movement, a multimodal passenger hub near Sabarmati HSR station is also taking shape. The hub will integrate connectivity to the Sabarmati HSR station, Western Railway stations, metro station and BRT corridor. The work on piles, foundations, piers, pier caps, casting and erection of girders for viaduct and stations has started along the alignment. Casting yards have been developed along the alignment to cater to the peak requirement of superstructure casting and erection. The 40 meters full span box girder weighs about 970 metric ton, involving 390 cubic meter of concrete and 42 metric ton of steel, and is cast in a single piece, that is, without any construction joint. Using indigenous heavy machineries like straddle carrier, bridge launching gantry, girder transporter and launching gantry, full span girders erection work is on progress. This 1100 ton capacity machine lifts the girder from the girder transporter by lifting beam and brings it between two pillars and carefully places it on the bearing placed on the pillar. This process is called girder launching. In this way, a 40-meter bridge is built in just 16 hours. Currently, 8 such machines are working, out of which 4 are completely made in India. The HSR stations are also taking shape along the alignment. The construction work of bridge on Par River, Poona River, Midhola River, Ambika River, Auranga River and Petalad Canal has been completed. The bridge works on important rivers like Narmada, Tapti, Mahi and Sabarmati are also in progress. With the use of full-span box girder launching technology, the construction of viaducts over railway tracks and roadways is progressing rapidly without disrupting traffic. Breakthrough of first mountain tunnel of 350 meter has been completed in Valsad district in Gujarat. First steel bridge of 70 meters length has been erected in Surat district. This is the first of the 28 steel bridges which will be the part of MAHSR corridor. The laying of first reinforced concrete track bed for the MAHSR corridor track system as used in Japanese Shinkansen has started in Surat. This is for the first time J-slab ballastless track system is being used in India. Ensuring unhindered scenic view for passengers, noise barriers are being erected on either side of the viaduct. The rolling stock depot in Surat is also taking shape. As we step into Amritkal, India's first bullet train, the Mumbai-Ahmedabad high-speed rail corridor project will not only be a glorious example of our Atmanirbharta, but will also be pivotal in putting India on the track to global prowess. The National High-Speed Rail Corridor, accelerating transformation toward New India.
So we have 1 minute with us, and we have seen the epitome of Indo-Japanese friendship, which is coming up between Ahmedabad and Mumbai. If anybody has some question, they can ask. We have time for 1 or 2 questions.
Yeah. Good morning, sir. My name is Arun Gupta, and I am very happy to be here and part of your presentation. I've traveled in Shinkansen, not in Japan, but in China, and I was very much impressed with the stations and everything. I am looking forward to India be on that league. Just as a matter of curiosity, our Delhi Chief Minister has said that Shinkansen ticket will be 75,000 rupees. One of the videos he had told.
So he's asking about the ticketing of this, that one of the politicians in India asked for, that it could be exponential. So what sort of planning is happening, sir?
Let me tell you, fixation of the rates have not been done so far. Ticket rates have not been fixed, have not been finalized, but it is going to be comparable with any of the advanced countries, rather much cheaper, and it will be very much comparable with your air travel, less than air travel, that is for sure, and time taken for Ahmedabad to Bombay is going to be even less than what you spent while basically traveling by air. Because it takes almost 2 hours there at airports for check and check out. In our case, it is going to be 2 hours 7 minutes only.
I think this is a very great achievement this will be, and will develop that area in a big way, like Osaka and Tokyo developed when this Shinkansen was started there. We look forward to.
Thank you very much. Thank you, Sonal.